Section 4.8 is called Applications and Models, and we're just going to do a couple of right triangle examples. So it's not a very long section. The first example says solve the triangle where A is 18.9 centimeters, little c is 46.3 centimeters, and capital C is 90 degrees. So remember, solve the triangle means find all the angles and all the sides. It might be helpful to draw a little picture. Notice when they use this notation, they don't have to give you a diagram, you can figure it out. So since C is 90 degrees, you know this is a right triangle. I'm just drawing, this is not the scale, I'm just drawing a triangle. So capital C is 90 degrees. Remember, little c is across from capital C. So little c is 46.3 centimeters. And it doesn't matter which one you call A and which one you call B. For example, if I call this capital A and this capital B, just as long as you're consistent, little a is across from capital A. So that's 18.9 centimeters, which means little b is over here. Okay, so we need to find the remaining two angles and the remaining side. Well, you could use Pythagorean theorem to find the remaining side. Why don't we just go ahead and do that and get that out of the way? So b squared plus little a squared, 18.9 squared, is the hypotenuse squared, 46.3 squared. So b squared plus 18.9 squared is 46.3 squared. I'm going to wait. I'm not going to punch it in yet. Let me get b squared. So b squared is 46.3 squared minus 18.9 squared. Subtract 18.9 squared from both sides. Now I'm going to go ahead and punch that in. You see, I waited to punch it in because why punch that and write a long decimal and then do that and write a long decimal when I can just do it once. So 46.3 squared minus 18.9 squared is 1786.48. 46.3 squared minus 18.9 squared. Right. And then B is going to be the square root of that, which is 42 point, I'll just go to two places, 27 centimeters. And again, if you want to add it in your picture to use for something else, you certainly can. Okay, so there's B. So we have all three sides, right? We have all three sides. Now we need the angles. Notice if we find one of the acute angles, we can get the other one by subtracting from 90. Now how do we do that? All right, this goes back to what we did several sections ago. When you're trying to find items in a right triangle, if you know two sides, you can certainly find the third with Pythagorean theorem like we did. But before, when we didn't know, say, two sides and we knew an angle, what did we do? What was the procedure? Choose one of the acute angles and two of the sides, right? That's three variables, so to find one of them, you need the other two. Now, what we typically had before was we chose an acute angle and two sides. We knew an angle and we knew a side, and we used it to find another side. So we never did an example where we had two sides and we were trying to find an angle. But now that we finished section 4.7, we can do that now. That's why we didn't do them before. We needed section 4.7. Okay, so which angle do you want to find? Well, let's just find angle B because it's staring right in front of me. So what do? You choose one of the acute angles and two of the sides. If I wanted to use little b, I could. As I've said before, I like to use what was given because I rounded this answer and I don't want to round on the rounding. But you certainly could if you wanted to. Okay, so I'm choosing this acute angle B and the two sides. Then what was the next procedure? Ask yourself what trig function relates this angle to those two sides. This is adjacent and hypotenuse, so that's cosine. So cosine of B is the adjacent side, 18.9, over the hypotenuse, 46.3. Right, so cosine of this angle, cosine's adjacent over hypotenuse. Now, I'm not going to type that in. You could type it in and get some decimals, but how do you solve for B? Remember in the last section, cosine of an angle is a number. So the angle is cosine inverse of the number. Right? Cosine of an angle is a number. Cosine inverse of the number is the angle. Now remember, B needs to be acute, and that's what the calculator is going to give us. When you take cosine inverse of a positive number, remember where cosine inverse lived. Cosine inverse gave you an answer from 0 to 180 degrees, or 0 to pi radians. And since this is a positive number, it's going to give us an acute answer. So we're okay there. So if I'm in degree mode, I'm just going to do this in degrees. It didn't say, oh, since C was given in degrees, we should be consistent and give B in degrees. I am in degree mode. So cosine inverse of 18.9 divided by 46.3 is about 65.91 degrees. Okay. Now we could find angle A, just it's the complement. A is the complement of B, but just to do more practice with this, let's pretend that I hadn't done B yet. Let's pretend. Okay, so let's pretend instead of doing B, I had chosen to do A instead. Okay, certainly on a test, you'd probably just want to subtract that from 90 and be finished with the problem. But just for practice, let's find angle A, assuming we hadn't done B. So you choose the acute angle and two sides. Okay, now what trig function relates angle A with these two sides? It's opposite in hypotenuse, so that's sine. So sine of angle A is opposite of A, 18.9, divided by the hypotenuse, 46.3. So notice we could find A without knowing B. So sine of an angle is a number, so the angle is sine inverse of the number. Right? So sine of A is opposite over hypotenuse, that's where this came from. Sine of an angle is a number, sine inverse of the number is the angle. So A is going to be, again, I'm going to do it in degrees. Sine inverse of 18.9 divided by 46.3 is 24.09 degrees. And notice we know we're correct because these two angles add up to 90 degrees. We knew that was going to be the case. Okay, so that's the first example. So again, we could have almost done this problem before. We could have set it up to here a couple sections ago and set this one up, but then we didn't know how to do the inverse functions. We didn't know how to get A from here, but now we do. Okay, so the procedure is the same. When you're solving right triangles, what do we have to use? You know that the sum of the acute angles is 90 degrees. You have Pythagorean theorem, and you have the choose the acute angle and two sides, set up the trig function, and then solve. Okay, so that's all we need to solve right triangles. Now, the next thing is two definitions, the angle of elevation and the angle of depression. I'm just going to draw a picture and illustrate what it is. So first, angle of elevation. So suppose we have I'm going to draw two pictures, give yourself some room. So suppose we have a person here, and here's the sun. I know it looks like a third grader drew this, but that's all right. I'm not very artistic. Okay, so let me make a right triangle out of this. So he's looking at the sun, that's the hypotenuse, and I'm going to make this a right triangle. Okay. Okay, so suppose this person is looking straight ahead, right? He's looking straight ahead even though he doesn't have any eyes. So he's looking straight ahead. The angle of elevation is measured from the horizontal up. So his angle of elevation is what angle does he have to raise his arm to get to the sun? Okay, so his eyes, I mean. So through what angle does he have to raise his head to see the sun? So this right here, right, from the horizontal up, this is the guy's angle of elevation, right there. Okay, so you measure from the horizontal up. Through what angle does he have to raise his head to see the sun? That's the angle of elevation. Okay, likewise, right, so let me put the person up on, I'll say on a cliff. So he on a cliff. And there's a friend down here. Right, and let me again draw a triangle from his eyes, say, to this person's eyes. Okay. Now we want to talk about the angle of depression. So it's the same idea. It's measured from the horizontal, but the angle of depression is measured from the horizontal down. Okay. Angle of elevation is horizontal up. Angle of depression is horizontal down. Now let's look at this picture. So for this guy to see his friend down here, where's the angle of depression in this picture? This person's angle of depression. Now you'd be inclined to put it right here because of the way I've drawn the triangle, but be careful. Don't let the picture mislead you. Remember, angles of elevation and depression are measured from the horizontal up or down. This isn't the horizontal and that's not the horizontal, so be careful. Don't let the picture mislead you. His angle of depression is measured from the horizontal. down. So, through what angle does he have to move his head to see the friend down at the bottom of the cliff? So this is not the angle of depression. If you want to draw it in, you have to add to the picture. That is his angle of depression. So it's not in the picture that's drawn, that I drew for you. So be careful. You may have to add to the picture to draw in the angle of depression. His angle of depression is here. Now let's look at this guy. Where is his angle of elevation to look up at his friend? Well, for him, it's the angle. It's the measure from the horizontal up, right? The horizontal up. So where is his angle of elevation? There's the horizontal, so he'd have to raise his head through that. So that's his angle of elevation. So notice his angle of elevation is in the triangle, but his angle of depression isn't. Now, what do you notice about his angle of elevation and his angle of depression? Perhaps you remember from your high school geometry, if two parallel lines are cut by a transversal, alternate interior angles are the same. Okay, so if two parallel lines are cut by a transversal, alternate interior angles are the same. So his angle of elevation is his angle of depression. So if the problem said something about his angle of depression and you didn't want to add to the picture, you could just say it's his angle of elevation and put it here. Okay, so they're the same, it doesn't matter. Okay, let's do an example using these angles. So the example says a cellular telephone tower that's 120 feet tall is placed on top of a mountain, that's 1,200 feet above sea level. Okay, but let's just stop right there. So here's sea level, okay, here's sea level. And we have a mountain that's 1,200 feet above sea level. Okay, so here, I'm just gonna draw a vertical line for the mountain. Okay, so here's the mountain, and it's 1,200 feet above sea level. Okay, so this is 1,200 feet from here to here, 1,200 feet. Okay, and the cellular telephone tower is on top of that mountain, and this is 120 feet. So on top of this mountain, we have this tower, right? So there's the cell phone tower that's 120 feet more than the 1,200. Okay, so the mountain's 1,200 feet, the cell phone tower is 120 feet on top of that. That's the first sentence. What's the angle of depression from the top of the tower, so the top of the tower here, to a cell phone user who's 5 horizontal miles away, okay, so 5 miles this way, and 400 feet above sea level? Okay, so the person on the cell phone is not here because they're not at sea level. They're 400 feet above. Okay, so this is 400. Okay, so the person's 400 feet above sea level, and the person's here. I'll just put an asterisk. And he is 5 horizontal miles away. Okay, I think that, let me check myself. A cell tower that's 120 feet tall is placed on top of a mountain that's 1,200 feet above sea level. What's the angle of depression? I still have to draw a triangle. From the top of the tower to a cell phone user who's 5 horizontal miles away. Right, well, from the tower, same thing. And 400 feet above sea level. Okay, so this is 400. Okay, so if I draw the triangle like this, and I'm assuming that this is a right triangle, it says, what is the angle of depression from the top of the tower? It's the same situation I just had. That is not the angle of depression. The angle of depression is here. But that's the same as this person's angle of elevation, which is from the horizontal up. So I'm going to call that theta. That's the angle. His angle of depression is his angle of elevation. So I'm looking for theta. So it's finding something in a right triangle again. Now we have another issue here. Notice all of these units are given in feet, and this is given in miles. So if we want to do everything, it's easier to change this to feet than change everything else in miles. So let me change this to miles. Remember, 1 mile is 5,280 feet. Okay, so remember our unit conversion discussion. If I have 5 miles, put that over 1, I want to convert from miles to feet. So miles go in the denominator because they cancel. I want them to cancel. And then I have feet up here. And then, right, how many feet or how many miles, right? So argue units first. I want miles to disappear and I want feet. and then 1 mile is 5,280 feet. So when I multiply, I'll get the total number of feet. 5 times 5280 is 26,400 feet. So this is 26,400 feet. Now, everything's in feet, so I'm not going to use the miles units there. Okay, now there's one extra thing. I want to use this triangle right here. I'm trying to find theta. It's a right triangle, and this distance is 26,400 feet. So to find theta, I need another side of the triangle. I don't know this one. I have measurements over here. Now the triangle is not down to here, okay? I'm using this triangle right here. I need the distance from the top of the tower to where this person is standing. Now how do we figure that out? Remember, 1,200 from here to here, and then we have an extra 120. So that total distance is 1,320. So from here to here is 1,320 feet. But remember, this distance here is 400 feet. Okay, so from here to here is 1,320. That's 400. So to get the distance from here to here, it's 1,320 feet minus the 400 feet, which is 920 feet. So from here to here is 920 feet. Goodness, there's a lot going on in this problem. Okay, so from here to here is 1,320. From here to here is 400. So 1,320 minus 400 is the 920. So that's this triangle here. So let me draw this, the triangle we're interested in here so you can see. So this is 920 feet, this is theta, and this is 26,400 feet. So this triangle right here. Okay, and we're trying to find theta. Okay, so what do? We choose an acute angle and two sides, and then you ask yourself what trig function relates to that angle to those two sides. This is opposite and adjacent, so that's tangent. So tangent of theta is the opposite over the adjacent. Tangent is opposite over adjacent. And tan of an angle is a number, so the angle is tan inverse of the number. So all we have to do is punch that in. Okay, let's see what we get. None of the angles are given in this problem, so so you could use degrees or radians. I'm already in degree mode from before. I'm just going to use degrees. So tan inverse of 920 divided by 26,400 is about, if you round to 3 places, it's 1.996 degrees. 1.996 degrees. Okay, so the only new thing, well, there's 2 things in this section. One is the definition of angle of elevation and the angles of elevation and depression. And then the second thing is solving a right triangle when you know 2 sides and you're looking for an acute angle. Right? Choose the acute angle and 2 sides, then ask yourself what trig function relates them. Set it up just like we did a couple sections ago. Tan of an angle is a number, tan inverse of the number is the angle. There we go. So that's the only new thing here.